All right, so you're doing biochem and they're asking you the charge of the peptide. But who knows? Well, here's how you can know. But first, let's start with the basics. All right, so let's look at this one at a time. This is going to be very neutral of a pH at 7.4. Let's just look at the acids for now. Whenever we have a pKa that's lower than that pH, we're going to be deprotonated because there's not a lot of hydrogen, so this is going to deprotonate. The acids want to pull the pH down, so they will deprotonate to put more hydrogens into the solution. Now let's look at the base. Bases want to take the hydrogen. So whenever pH is less than pKa, there's a lot of hydrogens here that they can take from. So when we have a neutral pH, it does two things. The acids deprotonate because they want to put their hydrogens into the solution. The bases get protonated because they want to take the hydrogen ions. This results in a negative charge for acids and a positive charge for bases. Now, don't forget, we do have the amino group and the carboxylic group. The amino group always goes up here at the top, and then it goes from N to C. Because our solution is neutral, we have a pH that is greater than our pKa. So this would be deprotonated. So our carboxylic acid would have a negative charge. Now, with our pH of 7.4, it is less than 9. So we're going to be protonated. So this guy is going to give us a positive charge. Now we want to look at glutamate, lysine, aspartate, and aspartate. If we just look at the acids, 4.1, 3.9, both of these are less than 7.4, so they're going to fall in this range. Again, this is 7.4. So since these 4.1 and 3.9 values are less than, they're going to be deprotonated, they're going to be negative, 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 negative. So now we have 1, 2, 3, 4 negatives. Now, if we look at the lysine, this has 10.5, it would fall in here. This is going to be positive. If we add these up, 2 positive, 4 negative, we have an overall charge of -2. Now think of my marker as a slider for the pH. Right now it's neutral, but then what happens if it becomes more acidic? What's going to happen is there's going to be a higher hydrogen concentration. Therefore, more things are going to be protonated. As we go this way, things become more basic. There's less hydrogen concentration. More things will be deprotonated. So now what we find is whenever pH is lower, you should expect that you're going to have more positively charged amino acid polypeptide chains. And whenever we have a more basic solution, so again, higher pH, we're going to have less hydrogen ions in the concentration of the solution. We're going to have deprotonation, which is going to result in more negative amino acids. And this was Chaser Bordy with the game plan for your academics. So see you guys in the next one.